Okay, this video is going to talk you through designing your first class. There are several things that I will expect that you guys be able to do when you design a class. The first thing I want to talk about is that I'm going to expect you guys should create your classes and design them in what's called a class design planning sheet. This class design planning sheet is actually what we call a UML diagram. UML stands for Unified Modeling Language, and you can do a Google to actually learn more about that, okay? But a couple of things here. This is actually a little bit more involved than a UML diagram. When you do a UML diagram, I will expect that you have the name of your class here. You want to list all the instance fields that you have. And some of you have worked with classes before in your other programming classes, some of you have not. So I'm going to be talking about the general setup for designing a class, and you should make all your instance fields private. Okay, we'll talk about that in a little bit. Constructors we will talk about in terms of creating a class called a circle here in just a minute, but a constructor is what actually creates that object. Those of you that had Greenfoot, you guys were used to that when like we would create and put a new crab on the screen, or we put a new lobster on the screen. Every time you did or used the new keyword, you were constructing an object. You will get to decide how your constructors work in the class that you create. I will show you how it works when I design a circle class today. And then you have other methods. Now typically when you first design or create a class, you have getters, you have setters, and then you have mutators. Your getters are typically named get. For example, in Greenfoot, you had get x, get y. Those are getter methods. They get it or they return a value from the class. Setter methods generally set a value for one of the instance fields. And mutator methods are the methods that kind of basically do everything else. Some programmers count setters as mutators. I'm not going to differentiate between those. But here's the deal. Today, we are going to go through and create a circle as a class. And I probably should back up because this particular chapter, or the standard that we're working on, is talking about classes, objects, and data structures. And so I'm going to introduce you today in C++ on how do you create what's called a class. Once you have a class defined, then you can create the objects, okay? And so that's the process that we're talking you through. You guys should begin reading chapter 8 in your textbook because it'll talk more about designing classes. You guys will then choose a class from this list, page 497, and design a class before Friday. Now if you notice, what's the very first thing that you have to do is you have to create a class diagram, and then you have to get it approved before you write your coding. The other thing that you should do is create test data, and then you should get your test data approved. So you could actually do 1 and 2 outside a class so that while you're in class, you're actually writing the code. But when I walk around tomorrow and the next day, I'm going to be expecting that you have these 2 things done before you actually write a single line of code, okay? After you write a class, then we're going to talk about how do you write a driver program. You guys have been writing driver programs from the get-go this semester. That's basically all you've been doing. You have not been using object-oriented design. You have been learning the C++ syntax. You have been learning how to output to the screen. You have been learning how to input. You have been learning how to concatenate strings. You have been learning how to use the AND and the OR operators, etc. Okay? Your driver and main will be in a single CPP file at this time. And then when you're done, you're going to submit that class. This is the one that you have to have done by the beginning of class Friday in order for me to do the next lecture, okay? Depending on how long this lecture takes today, we may adjust that, all right? But that's the idea. Okay, I have done some pre-planning, so I created a class diagram before we started. This is my class diagram for a circle. So the name of the class goes first, that's the circle. I have 1 instance field, and I want you to take a look at this class diagram. Everything in the class diagram means something. This minus sign that's right in front here means that it is private data. All instance fields should be private until further notice, okay? The data type comes next, and then radius. Now some class diagrams might have the minus sign for the instance field, the name of the instance field, and then a colon followed by the data type. But as long as you have the name, the data type, and whether it's private or public listed there, I'll count that as complete. What might be some other instance fields I could have thought of for a circle? What else might I want to calculate or find out about a circle? Say it louder. Any ideas? No ideas? Okay. Sometimes you guys will say that we want to maybe have the area up here, or that you want to have perimeter here. I'm going to argue against that. If you notice, where do I have my area and my perimeter down here? Actually, not perimeter, but I have get area as a method. And the reason for that is to prevent stale data. If I were to make a variable up here, an instance field for area, every time I change the radius, what would I have to do? Every time I change the radius, I should go ahead and calculate what? The area, okay? So it prevents stale data if you keep your classes restricted to the absolute bare minimum of what defines that. And what I'm saying right now is that a radius defines a circle, okay? Now, I'm going to have two constructors. My constructors, or the constructors, both have to have exactly the same name as the class. One of them has parentheses, nothing inside, and one of them has parentheses, double. What goes inside the parentheses are the parameters that you send into the constructor. If I don't have parameters, it's called a default constructor. If I have a parameter, that means I'm sending in a value. Please notice I don't include the variable name right here. It's just the data type. Also, please notice along the left-hand side, there's plus signs, okay? The plus signs mean that they are public. So your constructors are public, and so are most of your methods, okay? The other methods that we're going to write are set radius, and get area, okay? Remember that back on the template, you had your setter methods and your getter methods. This is an example right here. You have set radius and get radius. When you are first learning how to design classes, it's pretty common for every instance field that you have, we have an instance field called radius, that you create a setter and a getter for that. Now here's the deal, guys. I'm expecting this to be done before you write your class. This is actually the bulk of your work. If you can write this before you actually design your class, then your class is going to be very, very easy to write. If you don't take the time to dig in and really understand what instance fields you need, what methods you need, it's going to take you 3 or 4 or 5 times as long in order to create your class. Please notice the definitions listed below here. You need to know what an overloaded method is. An overloaded method has the same name and different parameters. I have an example of overloaded methods here. The default constructor and the parameterized constructor are examples of overloaded methods. They're both named circle, but they have different parameters. So same name, different parameters are overloaded methods, okay? All right, so far, all we have done is talked about what is a class diagram, how would I set up a class diagram for a circle, and the next thing that we are going to do is to actually go to Visual Studio and create your class, all right?